So, I introduce you to our bridge, Reverend Tom Cruise Sr. II. It's the second because we made another first one, and then Eli destroyed it, so we had to make another one. But so as you can see, there are two main sections of the bridge. There's this part over here with the syringes, that's what you call them, and then it extends over to the part over there, which is just where the other side of the river or wherever we're connecting, maybe a gully or something, and and so then really cool. We have our orange boat. I don't know if you can see it in the camera or not, but it's really cool. It's an orange boat, and basically our task is we have to lift the whole bridge so the boat can go through. I guess it would be a river then, wouldn't it? Not a gully, because boats can't go through. Okay, whatever. But so anyway, we have to put a 2-pound weight on the syringe and have to move the entire bridge. Now, in some engineering terms, we have to have a mechanical advantage of 4. This means that we have to be able to lift 4 times the weight that we put on it. So if we put a 2-pound weight, it has to be able to lift 8 pounds essentially. Would be that would be a mechanical advantage of 4. So I think we are, for the most part, ready to demonstrate. And another thing I may note is the gear train that helps with the mechanical advantage a little bit. So yeah, I think we're ready to demonstrate it.
Okay, so we just have this 2-pound weight here. I'm gonna place it on. Maybe. Sorry. Oh my gosh.
And the boat is through. Success.
Yay!
Yay! I'm proud of you guys.
Alright, so from the old stuff we've done, what kind of joint is this? Or what kind of connection is this? No.
Pinned?
I can't see it. Pinned and
Nothing.
roller. It'll prevent it from going further down.
Oh, okay.
Point of a roller.
We have a 2 chain and sprockets, and the syringe is attached here, and that's supposed to push that down. Then it goes to a gear train. Then it lifts up the bridge. We're supposed to use a 2-pound weight, but that won't work. So I'm just gonna press it down now. Okay.
Okay.
Okay, that's great. So I don't even know if the boat will fit through here. Wow, no. Cool.
So this is Richard. He is
Richard.
He is a 1-part drawbridge, and we included the use of 2 spools that we decided to use as pulleys, and we attached string through them, poked holes through the bridge, and then attached them. Now, I just like to mention, it looks very high. I'll give it that, but the bridge cannot pass through. Okay, just giving that. Now, once I put the 2 weight on, the bridge cannot pass through Richard.
What's the mechanical advantage?
From my calculations, it was about 3.85.
Almost 4.
Almost 4.
Any other things you'd like to say about the bridge?
I like Richard.
Richard's kind of temperamental, but he decided to work.
What kind of pulleys are those at the top?
Fixed.
What's the mechanical advantage of a fixed pulley?
It's 1.
It is 1. Thank you, class, for helping.
So this is Noah, James, and I's project, our bridge. So basically, we actually modified this design quite a lot from what it used to be. Originally, we had this syringe right here just pushing down. Actually, we had it push up so that this would raise when it was connected to it. But now, to increase our mechanical advantage, we added a lever right here. So this actually pushes down when it's connected to that syringe. In fact, I don't know if you can see that. And so when that is pushed down, this actually extends, and that raises this lever, and that raises this little part here, which allows us to open up the bridge. So there we go. And there it goes through.
Cool. What's the mechanical advantage?
About 3.
About 3?
It is
A little
3.
over, yeah.
We have two syringes that are taped to this lever, which is actually a wheel and axle. And when we press the syringe, it turns the axle, which then turns the gear, and then connected to this other gear, which turns that axle. And we have a chain and sprocket over here, which moves the axle that the bridge is connected to. And the bridge is laying on the second part of our bridge design, and it just holds it up. And the mechanical advantage I got was 1008, which is pretty good, but it obviously doesn't go through now. So.
Bridge very easily goes, or boat very easily goes through.
Yes.
Beautiful.
Yeah.
Alright, this is our project. We are Madeline, Thomas, and Chandler.
So we picked this design because of its simplicity. Overall, if you look at this, it did not require a large number of VEX pieces, which is good because at the time that we started building, most of the pieces were taken from the previous project. So we didn't have a whole lot of variety to work with, so we were able to make this work with what we had. Yeah, I mean, it does what it needs to do, and we did achieve a mechanical advantage of 5.25.
All right, so here's how the project works. We have a hydraulic small syringe here attached to a weight. It goes up to the large syringe, and large syringe is attached to a pulley system, mechanical advantage of 3, because it has 3 supporting strands. And what it does is it has a bar here, and you pull out the pulley, and the bridge raises, and you push in the pulley, and the bridge lowers. So that's pretty much how it works. So, now this side. So what we do, pull it up, bridge will go through, or the boat will go through rather. Not that.
Very close.
Very close, however, it does go through.
Does it work by using the weight?
It absolutely does.
Yeah.
What's the mechanical advantage?
5.25. We got a 1.75 out of the syringes and a 3 out of the string. Ends up being a total of 5.25. Not too
What
bad.
kind of pulley system do you have?
We have a block and tackle pulley system. As you can see, the bridge can't go through while the syringe is closed, or the boat can't go through while the syringe is closed and the bridge is down. We have a block and tackle pulley system. The fixed point is to the actual bridge, and then we have 2 pulleys on top above the bridge and 1 pulley on the bridge.
So this is me and Christian's project. The way it works is you pull the syringe with the weight, and through the pulley it pulls up like a medieval drawbridge. Has a mechanical advantage of 6.1, and yeah, that's pretty much it.
So for the mechanical advantage, how we calculated that, the pulley, or the block and tackle here is 2, because there's a pulley there and a pulley here. Our bridge deck itself provides a mechanical advantage if you calculate from the center of the bridge, because this is pulling farther than it is in the middle. And then our last part of the mechanical advantage was the syringe itself, which provided mechanical advantage of itself of 1.22, which gives us a total mechanical advantage of 6.1, as Clay said. So now I can show you guys how it works. So similar to Thomas's, if we pull up on the syringe, it will raise the bridge. And Clay will demonstrate the bridge going underneath.
Boat through.
And then by setting a weight on top, it will push the bridge back down.
What kind of lever do you have for your bridge? So where's your effort at?
Our effort would be at the end of the bridge.
Okay, what's in the middle?
Our force.
What do you mean force?
Would be our
If the effort's on the end, resistance is in the middle, so what
Resistance,
class
yes.
lever is it?
Third.
Third.
Second.
Free, 1, 2, 3.
Second.
Second class lever. What kind of pulley do you have? Well, what's the kind that's attached to your bridge?
Block and tackle.
Nope. It's a block and tackle if there's more strands. You only have 2 strands. It's a movable pulley. What about your other one?
Other what?
The
Pulley up there.
pulley that's up at the top.
Fixed pulley.
Yeah. What's the mechanical advantage of a fixed pulley?
1.
Okay, so how our project works is the syringe right here is attached to the weight, and you put the weight on here, and it lifts the bridge up like that.
Let's see the boat not going through and then going through. You don't have to be quiet. Nobody's gonna watch this video except maybe you
That's
guys
true.
later,
Alright,
or maybe
okay.
your parents.
Sure.
That's it.
Oh, you already pushed it down.
Mm-hmm.
Oh, wait, hold on. There you go. Can't fit through? Now it can. And even has 2 ways for travel. So flow of traffic can go this way and this way.
Voila. Beautiful.
And it does not have mechanical advantage of 4. It only has it of 2.33. But
How'd you get 2.33?
through the syringe, it goes down 3.5 inches and it goes up 1.5 inches.
Okay. What about the roadway? You can use that as a lever. Where's the fulcrum of your road?
Right here.
No.
Wait, no, sorry, right here and right here.
Yep. So if you just look at the left side there, what is in the middle of your road as a lever?
The syringe right here.
So if this is the fulcrum over here, what's in the middle of your bridge?
Resistance.
Resistance, and what's on the end of it?
Effort.
Alright, what class lever is it?
Second.
Second.
Second. Resistance in the middle, it's the second class lever. Thank you very much.
So I'm Colin, this is Katie, and this is our bridge. Now, why we chose this design, it looks unnecessarily bulky, but that's just because I wanted it to be strong, so when actually working with it, it doesn't come apart. It's all made out of Vex pieces again, so it's like sturdy, and we made the bridge solely out of cardboard, so it's light and easy to work with. The mechanical advantage of this, assuming calculations are done correctly, are approximately 4.4, something like that. There's not much in the syringe itself. I think it's like 1.5, but the chain and gear system on its own has a mechanical advantage of, I think it was like 2. Yeah. So you can explain how this works.
Okay, so the weight will be applied over here, which will push this up, and the bridge is on the axle that this is like affected by, so the bridge will go up with that, and the boat will go through it. Does not fit.
I'm on JVB because it's my first year, and so I can playing time, as Aaron said.
Oh yeah. Fits through there nicely. Beautiful.